Hey guys, so this is pretty much the last of complex numbers. So I don't think this is massively difficult. It looks difficult when you look up here. This is the question set up, but it's kind of bordering on coordinate geometry, and all it is the distance of a line. So it's called the modulus, and the modulus is the distance of a line when you're talking about an imaginary number. So as you can see here, we've got z1 and z2. They love the z's in complex numbers. It's going to come from your exam, something like this. And it's asking us to find z1 with two little lines either side of it. And this means find the modulus. So the modulus being the distance, we just use the distance formula. So if you see z with two lines, right, it's square root of a squared plus b squared. And a squared being my real number, and b squared being my imaginary number. So a squared is going to be a is going to be minus 2 and b is going to be 3. So for the first one I'll write that out. So I'll write a is equal to minus 2 and b is equal to 3. But normally we don't have to write it out. We just sub it straight into the formula. So the formula is the square root of a squared, so I'm going to put it in brackets, so minus 2 squared plus b squared 3 squared. You can put that straight into your calculator if you want there, and that will give you an answer, but I was going to do it a slightly longer way. Minus 2 squared is 4, b squared is 9, so 3 squared is 9, and it's going to give me the square root of 13. Now, if it asks you to find to a decimal place, you'd have to find it to a decimal place, but I just leave it as the square root of 13 for the moment. Second one, find the modulus of z2. And again, this is a very popular question, it's very easy marks. So a is equal to 3 and b is equal to 4. Again, you don't have to write out your a and b, just put it straight in. In your exam, I would write out this part though, just to make sure you're getting your marks in case you make a mistake in your calculator. So again, I go 3 squared plus 4 squared is equal to the square root of 25, so that's going to be 9 plus 16. And the square root of 25, that's just third form. But to put it into a real number, we know that the square root of 25 is 5. Because 5 times 5 gives us 25. And finally, slightly harder, I suppose, but not massively harder, is when you're talking about the z1 plus z2. So, before we can do this, right, we have to add together z1 and z2. Okay, so we're not adding these two. We have to actually add complex numbers before we can start doing this. So I'm just going to get rid of the formula here for a second because I'm going to need a bit more space. And I'm going to go z1 plus z2. So we did this at the very start. I'm going to put them in brackets just to be sure. So z1 is minus 2 plus 3i plus z2. So z2 is going to be 3 plus 4i. Now if this was a minus, say for example it was z1 minus z2, it would change the signs of this bracket, but it's not, so we're not too worried about that at the moment. So I'm going to do minus 2 plus 3i plus 3 plus 4i. And then I can add together my i's, and I can add together my numbers. So minus 2 plus 3 gives me 1, 3 plus 4 gives me plus 7i. So that's what z1 plus z2 is. And now I need to find the modulus of it. So remember, I have to add them together, put them in brackets. If this was a minus, it would change the signs in there. So this is going back to what we started on last week. And the formula is, for finding the modulus, is z is equal to the square root of a squared plus b squared, as you can see there. So I am just going to get the square root of 1 squared plus 7 squared. So a is equal to 1, b is equal to 7. So I'm going to go the square root of 1 squared plus 7 squared gives me the square root of 50. We're going to leave it at that. That's the third form when you put it into your calculator. So this type, a little bit harder. It's worth a good few marks in the exam. Comes up all the time. Don't think it's that bad, but I'd say the trickiest bit is when we start mixing them together here.